Right. I hope you all are back. And so I'm going to share my screen again. So I hope you can see a pause video on the screen, right? So if you can't see a pause video, please let me know. In a while, I'll be playing this video. So the section we are going to start is the machinery principles, right? What we call as the physical component, right? And in this section, we are going to basically review the things you learned from the first year, right? That is what we are going to do. So we are going to do that through a problem, right? Before going into the problem, so to refresh your mind on the things, what we are going to do, as topics, what we are going to discuss about. So we will be discussing about the acceleration. So about acceleration, you should already know, usually we use the letter A to denote acceleration, right? Letter A. And the units. So units would be meters. So ms minus 2 power, right? Or else the same you can denote as squared over m, right? So that is, I'm talking about the linear acceleration here. So again, there is angular acceleration as well, right? Which we denote using the letter alpha, right? And the units of this one is going to be radians. This is kind of a review, radians for a square second, or else square second, or else bread is minus 2 power, right? To the power minus 2, right? So or else the same you can write as radians divided by squared. So here the letter S means seconds, meters. In this case, radians and angle. So in this case, it is linear. For this one, it is angular, right? Rotating motion. And this is seconds, the measuring unit of time. So these are the IS kind of IS units for, in other words, international metric units for measuring angular and linear acceleration, right? So you need to review this knowledge, and hopefully you know the displacement. Angular displacement is measured by meters, and acceleration is measured by radians or degrees, right? And the velocity is again much similar, right? So velocity here, I don't know if you are using mobile phone screen, if this is visible, so please forgive me for small words. So in my next lecture, I'll consider about that as well. So velocity, on the other hand, we are going to use mostly simple V for linear motion. And if you're talking about the rotary or as rotation, we are going to use most probably angular velocity. You can denote as again omega, right? Omega, right? So for rotary motion, and this is for linear motion, right? So these things you already know. And can you guys please send me in the chat box what is the unit, right, for velocity? And what is the unit for angular velocity? Right, linear velocity and angular velocity. Please send the unit. Thank you. I got one message. Right, a correct answer for linear velocity, and yes, correct answer for angular velocity as well. Very good. Yes, thank you very much. I'm really happy for you guys. You are responsive. Right. And what about this? Most of you guys have sent the unit for linear velocity, that is meters per second. And for this one, you need to know it is going to be radians per second, right? Right. So again, we are speaking about the right one incorrect answer as well, but I highly welcome your answer. We someone has said that you are measuring angular velocity, which is omega, using this unit, right? This is wrong. This answer is wrong. The reason is I just now said a while ago that we are using this same unit for acceleration. This is the unit of acceleration, right? Acceleration. So anyway, I welcome your answer. It's okay to give wrong answers, right? In that way you learn, right? Or else memorize. So this answer, this is the unit of acceleration, right? And it's again okay to give wrong answers. And what you need to know is the unit for angular velocity, right, is going to be this one, the metric one. And depending on other unit types, for an instance, in UK, in United Kingdom, they use different empirical units. So in that way, you know that how to kind of derive the unit for velocity. For an instance, another unit for velocity is miles per hour, right? That is another way, miles per hour. So which means how many miles you are going during 1 hour, right? So you can derive some other units as well, right? So I'm not going to discuss in detail about how to derive units because those are kind of first year basics, right? So this is just a review, but it's better to kind of remember the relationships. For an instance, how many kilometers are there, right? How many kilometers are there per 1 mile? So those things, it's better if you can keep in your mind, right? Right. So, and yeah, that's basically what it is. Going to our next topic. Right, very good. It's 1.6 kilometers roughly. Yes, really good. I'm really happy. And I'm really happy for you because you know things, right? Okay. The next thing is the force was torque. So torque in the sense is kind of the same component in rotary motion, right? So you know force is something that we use to push something with the mass to in order to make it move if it is at still, or else if it is moving to change its direction. So according to the Newton's law, we need something called a force, right? So we use the letter F to denote force. And the same thing if we are going to do, right, in a rotary motion, what you need is a torque. So we use the letter tau to denote torque, right? And of course, you know the unit of force is Newton, right? So it's kind of as an honor for the scientist Newton, we use the force unit Newton, but the same you can denote using SI unit as kg m s to the power minus 2, right? So you already know these two units are the same, right? These two are the same, right? And yes, and can you guys let me know what is the unit for torque and the spellings for torque? If you cannot remember, this is the spelling. So okay, it's here. Right. So torque. Can you guys let me know the unit? Unit for torque. So the question is in the chat box. Please send me unit for torque. Okay, I have got one correct answer and one incorrect answer. Right, two correct answers. So different types of answers as well, right? Right. So I feel like that. Thank you for all the answers. Anyway, thank you very much for all the answers. So whether it is correct or wrong, so you have the kind of the willing and the strength to give the answer, right? Sometimes even I don't have that one. So I really appreciate that. So you are forward. So that's kind of a sign that you have a good future, right? So I really kind of appreciate that. But again, I have a feeling that some of you need to kind of review your theory from the first year. The reason is the torque we measure by torque, the definition is torque is going to be the force, right? The same letter multiplied by the angular displacement. Angular displacement, we usually use the letter theta from the Greek alphabet to denote angular displacement. So force time, actually this is going to be the tangential force. So that is going to be the kind of the basic definition. But in your case, you have this radius. Sorry, yeah, forgive me about the definition. Force times the radius, right? So it's going to be r, right? So again, if I explain a little bit using this video as well. So let's go to the video and then we can get a better idea here. So it's going to be F times R, right? So which is Newton times meters, right? So okay, let's go to the video so that we can have a little bit of review, right? So I hope you should be able to see the video playing now, right? So basically what you're seeing here is a motor, right? So this is a motor, and we will be discussing about the construction of a motor later, right? Construction of the motor we will be discussing later, but for your understanding, I'll explain the basic components now, right? So the rotating part you see in the middle, right? So we call that, so usually in a motor, this is the rotating part. We call that shaft, right? So motor shaft, right? And this exterior part, which has some kind of metal bars like things on it, and this, including the standing, we call it housing or frame, motor housing or frame, right? and this little box here. So it has all the terminals inside that, right? So you can call it terminal box. Terminal in the sense, if I explain it in Sinhala, අපි connect කරන wire ටික තියෙන එතන. මේකට external power supply එකක් දෙන්න ඕනේ. ඒ wire ටික තියෙන එතන අපි ඒකට කියන terminal box එක කියලා. Right? So if you look from the other side, right, which means from this direction, you would see most probably in most motors there would be a fan as well, right? ගෙදර තියෙන fan අපි සාමාන්‍ය රස්නේ වුණාම fan එක දාන එකනේ සාමාන්‍යයෙන් කරන්නේ පළවෙනිටම වගේ. ඉතින් in the motor as well it get heated as it works, as it operates it get heated. Therefore to control the temperature, this thermal energy, you need a fan. In other words, to cool the motor you need a fan, right? So yeah, that's basically the construction of a motor. Now whenever you use a motor in a machine, sometimes what you would do is you would connect a pulley like thing, right? So what you know, I believe you know what a pulley is, right? So you have, you know, if you have a well at your home premises, ගෙදර ලිඳක් වගේ තියෙනවා නම් දන්නවා පුලියක් කියන ගොඩක් පිළ මොකක්ද කියලා. ගොඩක් අනිවාර්යයෙන්ම දැකලා ඇති. So you need to fix a pulley or a gear wheel or something like that, right? So gear wheel is, forgive me about my drawings, right? Basically it has tools and in between there is a hole to connect, that helps to connect it to onto a shaft, right? So gear wheel is something like this, right? I hope you have seen these things. So you need some sort of a gearing mechanism usually to connect a motor to a system, right? And sometimes you directly couple it to a rotating part as well. So anyway, the idea is you are using this motor shaft to connect it, right? So that you should keep in mind, right? So whenever we speak about the speed of a motor, right, what we are basically speaking about, so as you can see now, this shaft is rotating here, right? So when we speak about the speed, basically what we are talking about, that shaft speed. So you know that it's kind of a rotating motion, right? Rotating motion. So the shaft is rotating, and this speed, of course, you can measure using radians per second. But instead, in the industry, this you must remember, usually we use something called RPM, right? This means rounds most of you may be already familiar with this, minutes, rounds per minute, rounds per minute, rounds per minute, right? So I believe you, most of you are already familiar with this one. So the idea is rounds per minute. In other words, how many rounds, right? So a round means it starts its rotation from one point, let's say this point, and come back to its initial position. So in this case, right, if you look at this motor shaft again, right, so you can see there is a black mark on that. So it starts from here to come back to the same position, right? If it comes back to the same position, right, it means one round. and it's going around and around. So you calculate how many rounds per minute, and that is going to be your RPM value, right? So usually this figure, right, in the industrial machines, it varies from again from very low values like 0 to maybe few thousands like 5,000, etc., maybe higher than that, right? And depending on motor type. So if you think of an AC something, there is something called AC induction motor. In those things, single phase motors you use at your maybe pumps and may etc. So it's around 1,200, etc., right? And there are DC machines which has RPM values of around 60 to 100, etc., right? So DC, small DC motors. So what you need to understand basically is depending on the speed, sometimes the motor type varies, etc., right? So those things we will, basics we will learn, right? Right. And then it comes the torque. From time to time I'll be checking my chat to make sure that you don't have any questions there. Right, right. So that is RPM. So RPM is again kind of another, what you need to understand is RPM is another unit for angular velocity, right? So, or else angular speed, right? Going on, the next thing is torque, right? So in this case, what you see is, okay, the thing I told you, the pulley is here, and you have a rope attached to the pulley, and there is another pulley which is moving freely, and you have a load, right? So anything something like that we can call a load, right, on the system. So this is our system or else motor, right? So there is a load, and right, so give me a second please. So now what we're going to discuss about is the torque. So you can have the feeling now that in order to pull this load in this direction, you need to apply a force here, right? So there would be tension forces, and this force would be the tension. So I'm assuming that these are kind of inelastic and lightweight threads, rope. So this is going to be tension, and the same tension would be applied here. So this tension would be there. Therefore, the force on this shaft here would be equal to the tension, which is again this load force, right? So if this is going to be, if this load is going to be 10 Newton, right? There would be 10 Newton here as well, right? So that is the idea. And yes, so what we are going to do here is the torque means if I kind of draw this entire setup here, right? So I'm going to erase everything. If I draw this entire setup here, you have a pulley, you have the rotating axle or as the shaft, right? And force is force is applied at a position like this, right? Now this is force. In order to calculate torque, right, to get to know torque, what you need to do is you have to multiply this force from the perpendicular distance r, right? Basically the radius of the pulley, right? So that is the idea. So in that way you can calculate the multiplication of these two is going to be torque, F multiplied by R, right? So I hope that is clear. Right, so continuing my video here. Right, so let's go to a small problem here, right? So you can see that this load here, right? I hope you all can see that. So this load, the weight is 2.5 kilograms, right? So weight in the sense mass, right? M is equal to this much, not the weight. Mass is equal to this much, right? Then you know that usually we take G as 10 Newton, meters per square second, right? 10 meters per square second. G, the gravitational intensity, sorry, acceleration. Then what I need you to calculate is the tension of this rod here. So calculate T1 and send it in the message. Calculate T1. I hope the problem is clear. Mass is given. So calculate T1. It's not moving. The system is at still. The system is not moving. You need to calculate T1. Right, I got an answer. Right, another answer. Right, I got like 4 answers, right? And the first answer is 25 Newton. The second answer is 25 Newton. Third answer is 25 Newton meters. And both and other answers are, I have a feeling like the same, this one, right? Now let me give you a little advice, right? So in your examinations as well, one thing you would do is you don't care about the unit. Remember, units are essential, especially being engineering technologists who are related to engineering. You must care for the unit. So in the exam, right, I'm talking about final exam, mid exam, or maybe whenever you are working in the industry as well, you will be kind of punished for this one. So this is wrong because you are using simple N here. You will definitely be punished for this one because you are using the units of torque, right? This is not the force. Units for force is this one. So this is going to be correct, right? This is the correct answer. And again, I highly appreciate people who gave these two answers, types of answers as well. You at least give an answer, but what I'm worried about is the answer is not correct. So hopefully now you can remember, right, memorize it, that the unit should be Newton, right? It's denoted by capital N, right? So the tension is that much. Right. Thank you very much for all the answers. Now, what we're going to do is, if the tension here is T2, calculate the value of T2. The second question is, what is the value of T2? Right? What is the value of, this is the first question. This is the second question. Calculate the value of T2 and give me your answer. And if you need any details to calculate that one, let me know that as well. So if the details given are not enough to calculate T2, please let me know. Right. Thank you very much. I get, I think almost all the answers I got are correct. So you know that I told you this is a lightweight, which means the weight is negligible. Sahallu, lightweight, and inelastic, which means it's not going to stretch, right? Inelastic rope. So that means the weight is not going to adapt, or as the tension is not going to change, right? The same tension would be everywhere, right? So therefore, the tension would be the same, right? If I explain it a little bit in Sinhala, මේ ගත්තු තන්තුව නැත්නම් ලණුව සැහැල්ලු අවිතන්්‍ය මට මතක විදිහට වචනයක තන්තුවක් ඒ කියන්නේ ඇදෙන්නේ නැහැ. එහෙම තන්තුවක් ගත්තාම අපි මේක අංශු වශයෙන් ගත්තාම අපි හිතමුකෝ මේ තන්තුව මම දන්වැලක් කියලා හිතුවා කියලා. දන්වැලක් කියලා හිතුවාම දැන් මේ කොනේ තමයි ලෝඩ් එක තියෙන්නේ. මේ දන්වැලේ පුරුක් වලට බරක් නැහැ. මේ පුරුක් වලට බරක් නැහැ. එතකොට මොකද වෙන්නේ? එක පුරුකක් අරගෙන මම බැලුවොත් එයා යටට F වලින් ඇදෙනවා. උඩින් F වලින් අල්ලන් ඉන්නවා. ඒක හින්දා එක තැන ඉන්නවා. එතකොට එයාගේ බරක් නැහැ. ඒ විදිහට දිගටම ගිහිල්ලා මෙතනට එනකම මේ කියන පොයින්ට් එක වෙනකම්ම එකම මේ කියන පොයින්ට් එක වෙනකම්ම එකම බලය එනවා. හරි? ඒක පැහැදිලි. හැබැයි මේක බරක් තිබ්බනම් මොකද්ද වෙන්නේ? සහ මේක ඇදුණා නම් වෙන ප්‍රශ්න. බරක් තිබ්බනම් ඉස්සෙල්ලා බලමු. බරක් තිබ්බනම් මේ හැම දන්වැලේ පුරකටම බරක් තිබ්බනම් පළවෙනි එක්කෙනා ගත්තාම එයා මත බලය F. හැබැයි දෙවෙනි එක්කෙනා ගද්දී එයා මත බලය වෙන්නේ F plus මෙන්න මෙයාගේ බර. මේ පළවෙනි පුරුකේ බර එනවා මෙතනට. මම මේ කතා කරන්නේ මෙන්න මේ හරිය ගැන. හරි? එතකොට පළවෙනි පුරුකේ බර එනවා. ඒක මම දාන්න එක පුරුකක බර සිම්පල් m නම් මෙතන සිම්පල් m. එතකොට මෙයා ගණ ගද්දි f + 2m. ඔය පුරුක් දෙකක් එයා ළඟ ඉන්නේ. ඒ විදිහට යද්දි මේ හරියට යද්දි ලණුවේ මේ හරියට යද්දි මෙන්න මේ සම්පූර්ණ බර එකතු වෙනවා මේකේ බරට අමතරව. සහ මෙහාට එද්දි මේක සැග් වෙනවා. ඔය වගේ ප්‍රශ්න ගොඩක් එනවා ප්‍රැක්ටිකල් ඇප්ලිකේෂන් එකකදී. මේක ඔයා ඔළුවේ තියන් ඉන්න ඕනේ. මේ වගේ කැල්කියුලේෂන්ස් නැත්නම් ඩිසයින් ඔයා කරන්නේ නැහැ. You won't be doing designs like this. So most probably you would do is a rough estimation. The reason is compared to this load, right? Compared to this load, the weight of the rope is always negligible. මේ ඔයා උස්සන්න යන බරට සාපේක්ෂව ගොඩක් වෙලාවට මේ තන්තුවේ බර negligible. නොසලකා හැරිය හැකියි. ඒක නිසා ඔයා සාමාන්‍යයෙන් මේක සැහැල්ලු තන්තුවක් විදිහට සලකන්න. And about the elasticity, if this is going to be elastic, මේක ඇදෙනවා නම් the problem is it's going to kind of absorb some energy, right? So it's going to absorb some energy and the forces are going to be different. So you know that in a spring action, so F is equal to I'm sorry, I cannot remember the case, K times delta L square or something like K times delta L, I think. So I'm sorry, I'm really sorry, I can't remember that now. So there are things like that, so that you need to understand, right? So I think there is something in the chat box. Right, yeah. Now you get the idea. T2 is equal to T1, so it's going to be 25 newtons, right? So I'm going to erase everything and I'm going to focus on this section here, the pulley, right? So when you look at the pulley, what you have is something like this, right? And inside right, this is a pulley. So forgive me if my drawings are not clear, right? I hope it's clear. So you won't see these parts, right? You would not be these parts because it's covered by this pressed plate, or as the pressed face, right? So the rope is going around this one, right? So it's going to kind of wrap around this one, and as the pulley rotates, it's going to wrap this rope around itself, right? So there are several turns, right? So not clear. Right. I hope now the situation is clear. Now your axle, or as the motor shaft, is somewhere here, right? Axle, rotating axis is here. So everything is rotating around this one, right? Right. So now if I enlarge this part, or as if I look at this from this view, right? So what you would see is something like this. You have the motor shaft, and I'm only focusing on the midsection, and you have several turns of rope around it, and this is going like this, right? And the T2 tension is here. Now my question is, if the radius, right? So one thing is I'm going to tell is that this rope is tangent, right? At this point, the rope is tangent to this cylindrical shape, right? At this point, and the radius of this cylindrical shape is 5 centimeters. right? This R value is 5 centimeters. Now calculate the torque. Send it in the message. Send it as a message. If the radius is 5 centimeters, calculate the torque. And if you need any other details, then the given ones, please let me know what details you need. I got like 2 answers already. And even I don't know the answer yet, but I have feeling like the people who send the answers have given correct answers, right? So yes, others can try as well. So I'll give you like 1 or 2 more minutes. Right? Really good. Right. So unfortunately, again, I appreciate people who give answers, but I got a wrong answer as well. Therefore, I'm going to discuss this part. So I just now told you torque is, right? So this one, the torque is equal to the force, right? So this force multiplied by the perpendicular distance, right? Or as the perpendicular component of the force multiplied by the radius, that's one way, or else perpendicular distance from the axis to the force, that is the other one, right? So anyway, it's going to be simply F multiplied F. Actually, this is going to be F cross R. So in vector summation. So in vector, not vector summation, in vector multiplication, it's F cross R. So I'm not going to discuss in detail about the vectors here. So the torque is again a vector that you should know. I'm not going to discuss that part. I'm only focused on the magnitude, right? Because that is what it is going to be important in most of the cases, right? Because as you are not going to do design, so in most cases the direction of the torque is not going to be applicable, right? So it's F cross R and simply cross R. So should be like F R sine theta, but in this case you can simply multiply R and F, right? So F you know T2 you know it's 25 newtons, and you have to multiply it by 5 centimeters. So one could simply say it is 125 Newton centimeters. That is one correct answer. If you want to convert it to the SI units, right? So what you would do is 5 centimeters is equal to 0.05 meters. Therefore, instead of 5 centimeters, you are going to multiply 25 Newton by 0.05 meters. So then you get the answer from Newton meters. So you know that it is going to be 1.25, right? In other words, you calculate it from Newton centimeters and divide it by 100, right? So then you get the correct answer, which is again 1.25 Newton meters. And don't forget to write the unit, right? Unit is very important. If you don't write the unit, you will lose some marks in the exam, right? So I hope now you have an idea about what we're talking here, right? So I got some other answers as well. I think let me see. There is a student who has used the unit RPM to measure torque. Again, I am telling you this is wrong. Unit for torque is going to be force, unit of force multiplied by unit of radius, right? So that is going to be Newton meters. right? So this is the correct unit, and this unit is wrong. So remember, you will definitely lose mark for that, right? So it's a kind of a severe mistake, right? So, but again, thank you for your answer, right? Going to our next section, next part. So now, as you can see, this load is going to move upward, right? So the load is going to move upward as this I'm sorry, motor rotates. What would happen is this load is going to move upward, right? Right. So let's say when you think of this motion, right? I'm going to pause somewhere here. When you think of this motion and forget about these values, right? So these are not important. These are empirical units. I'm not going to use in those things, right? So as I told you earlier, mass of this one is 2.5 kilograms, right? If this load is moving at an acceleration of, right, directly upward at an acceleration of 1 meters per square second, or as ms to the minus power 2, right? So now calculate the T2 tension here. Can you guys calculate the T2 tension here? Please send it in the message. I think I got 2 answers. One answer I have a feeling that is wrong. Let's wait for others to find the answers. 2-3 minutes, 2-3 more minutes. Again, another wrong answer, but highly welcome. Giving an answer at least, right? Right. Right. You can try. So okay, let me explain what it is happening here, right? So this is your cement brick. Okay, I have another answer. Let me check that one first. I have a feeling like that this answer is kind of maybe correct. Let's see, right? So if you consider the brick alone, right, you need to draw the forces since we are we are considering one-dimensional motion, linear motion vertically. So all the vertical force components I have to draw here, right? So I have the tension T1, I have the weight of the load this much. And as an additional information in this direction, I know the acceleration, right? And this is simple application of Newton's law of actually this is not Newton's law, but it's derived from Newton's law. F equals ma, the equation, right? In this case, this F here means the resultant force. So the resultant force I can rewrite as, right? So I hope the colors are okay. You can see T1. So if I consider, if I assume it is in this direction, this resultant force is in this direction, is equal to the summation of these two, the vector summation, which means T1 minus W, right? So this looks like omega, so it is W, right? The weight, and that is F. That is F should be equal to M, right? M times A, and I'm going to substitute these values. T1, of course, I don't know. That is what I am going to find. T1 I don't know. Weight, okay, weight is mg. M I know, G I know. So which means 25 newtons, right? And again, M I know, 2.5 kilograms. Multiplied by acceleration is, it's again in metric units. So no unit conversion, simply 1, right? So it's going to be, so 2.5 newtons. You know that when I multiply kilograms from m to the power m times s to the power minus 2, in other words, meters per square second, it's going to be the same units of Newton, right? So no unit conversion is required here. So T1 minus 25 newtons is equal to 2.5 Newton. Therefore, T1 is equal to 20. I am taking this 25 to the other side, so it's going to be plus, and the summation, the final answer is going to be 27.5 Newton. And the question is, what is T2? So you know that the same probe is there. So T1 is equal to T2. So it's true for all these cases because this is a lightweight, inelastic probe. So this is equal to T2. So this is our final answer, right? So if you have given that answer, you should be happy. If you haven't given that answer, still you can be happy because you at least gave an answer, and what you need to do is just improve, right? So review your theory from the test year, right? And yeah, now calculate the torque for this situation. Calculate the torque for this situation. Torque. The radius is, as I told earlier, 5 centimeters. So what is the torque for this situation? Right, I got one answer. At the moment, even I don't know what is the correct answer, but I have a feeling like this answer is correct. Right. So these are the answers I got. Let me write them on the screen. 1.375 Newton meters. 1.375 meters, capital M. 137.5 Newton meters. 1.374 Newton meters. All right. So let's find the correct answer first. So again, torque is equal to force multiplied by the perpendicular distance, right, from the axis. Right. Force you already know, 27.5 Newton. You have to multiply by 5 centimeters. And since I haven't asked to convert the final unit to Newton meters, I can directly write it as, so 27.5 times 5 is going to be 5 is going to be, if you have any questions, first let me know in the chat, right? So then you can turn on video, right? So if you have a question, please let me know in the chat first privately, right? So I hope it's a kind of a mistake. So I disconnected the student who switched on the not disconnected, switch off the video, right? So coming back to the question, so force is this much, the distance is the 5 centimeter. So 27.5 times 5 is going to be 275 divided by 2, right? Which is going to be 137.5, right? So 137.5. Remember, the unit is Newton centimeters. So it's going to be, the answer is going to be 137.5 Newton centimeters. So this is a correct answer. So no one has given that answer. The other possibility is you convert this distance to SI unit, which is 0.05 meters. So which means the same answer divided by 100, right? So it is going to be 1.375 Newton meters. Many of you have given the answer, I'm sorry, in Newton meters. So of course, this would be a valid answer, correct? This second answer is wrong. The reason is this capital M, right? So in the end exam, right, you would lose definitely some marks for wrong units. Remember that. And after the end exam, once you get to into the industry, people will judge you from these things. So if you are going to use wrong units, people will judge you. Definitely they will judge you that you don't have the enough capability, or as you are not intellectual, you don't know how to do things correctly. So therefore do it neatly and correctly, right? And this answer here again is going to be completely wrong, because in Newton meters this is not the answer. So if I compare it this one, right, this first case here, so here the unit, I can assume that it is that is what it is wrong, and I can deduct some marks. But in this case, completely this answer is wrong, right? Because there are no assumptions, so the answer is wrong. So you won't completely, you would lose the marks. So you have done terrible mistakes here. In Newton meters, this is completely wrong, right? So in this case, it's a mistake in the units, right? The third answer here, I can assume the figure is wrong, unit is correct. At least it's close enough to this correct answer here. Therefore, I can give some marks, right? I can give some marks. And in the industry as well, so it's roughly okay. But I don't know why a person cannot multiply 27.5 by 0.05, because you have calculators and everything these days. And in the exam as well, you will be given calculators. So therefore, in the exam, maybe if the marking scheme is too strict, this may be considered as a wrong answer as well, complete wrong answer as well, because you are given the calculator, right? So keep these things in mind. So be careful, whatever you are doing, do it correctly. So in this case, as I can see, what it has happened is, you know the equation, you know the values, all the other things are the carelessness, right? So I'm again highly welcome the answers. I'm just giving you some advice for your future works, right? So it's totally okay to do mistakes here. So this is a kind of a stage where you can do you are allowed to do mistakes, right? So yeah, I can understand. So again, I can understand that you can do mistakes here. So the mistakes here are totally welcome, and I'm not kind of this blaming you, right? So please understand, I'm just telling you, don't do this again. That is the message, right? So don't do this again. That is the message. So again, thank you for all these answers. I highly appreciate. There is a question: should the answer be in SI units? So SI units, in the sense, in this case, Newton meters. Actually, if it is in SI units, this should be in kg m s to the power minus 2 multiplied by m, which is kg m squared to the power minus 2. So this should be the SI unit. And maybe you are referring to this one here. So this is the correct SI unit. And if it is not given, or as if it is not mentioned that the final answer should be in SI unit, it doesn't have to be. So for an instance, you can use this answer here, right? This answer is applicable, right? 137.5 Newton centimeter is correct answer, because I didn't ask you to convert it to the Newton meters. But as a practice, it is a good thing to go with SI units as a practice, because especially let's assume that this is going to be a end exam paper question or some problem you are going to face in the industry. So this is not going to end here. Maybe in your next problem you are going to apply this answer. So in this case, in that case, next problem may be in metric units, so or else in different sort of units. So you forget that this is in Newton centimeters. You assume like this person did, you assume it is in Newton meters and go to the next step. So the answer for next step is going to be wrong because you forgot that it is in Newton centimeters. So it is a good practice to come to SI units always, right? So that application of that value in future problems is going to be kind of less problematic, right? Less complex, right? Right, I hope that so far the things are okay. Let's move on a little bit. So far we discussed about, so if I summarize the things we discussed so far, we discussed about torque, and the equation you should remember is F cross R. These are vectors, and you must remember the units, right? Newton meters. Next thing we discussed about force, and F equals ma we discussed, and acceleration we discussed, right? So those things we discussed. And acceleration, the unit would be this one, right? And force, the unit would be Newton. The same you can write as kg m s to the power minus 2, right? So as a summary, these are the things we reviewed. Now we are going to our next section, which is power, right? So let's say instead of a motor, horse is going to pull this load, right? So in that case, you know that horse is doing some work, right? So basically, if I go back to this position, what it is happening here is, I'm sorry, horse is lifting this load x distance, and if you know the weight of this thing m, right, so you know how to calculate the work done by horse, right? So I believe you know how to calculate the work done by horse. So let me give you the values. So the weight of this thing is going to be, again, let's say 2.5 kilograms, right? 2.5 kilograms, and this height is 5 meters, right? So if the G is the same value I told you earlier, let me know the work done by the horse in this process, right, in the chat. So if you need any additional if you need any additional details, please let me know in the chat. So I hope the question is clear. So the horse is lifting this load, which has a mass of 2.5 kilogram, height of 5 meters. Anybody? Right. I have got several answers. So let me tell you how to solve this problem. And I highly welcome all the answers, right? Okay, one exactly correct answer is there. So let me tell you how it should be. So the work done here is the energy, again, energy used by the horse is equal to, or as a energy kind of absorbed, not absorbed, saved by this as potential energy, the difference of the potential energy of this load, right? Something like that. So it is going to be mg delta h, so which is equal to 2.5 kilograms multiplied by 10 times H is 5. And what is most important is the final unit. In this case is directly joules. Remember, you use capital J to measure work or energy, right? Joules, work or energy. The unit is capital J. Same, of course, you can use Newton meters, right? Newton meters is again correct, right? So the simplification of this one is going to be 25 mgh, right? So 25 times 5 is going to be 125 joules. I hope it is clear, right? So people who have given different answers, please, I hope if you have any questions you can ask. I hope you now understand why it is wrong, right? So some have given 100, some have different other units. So again, the unit is, you should be careful with the unit, right? Now, let me erase these things for a moment. So now you know that we calculated it by using the difference of potential energy. In this case, the horse is moving the weight, right? Horse is moving the weight. So in that, how it is happening is there are friction forces, right? So on the horse and in between the horse's legs and the floor, right? So on the floor, the friction forces would act in this direction. On the horse, it would be in the other direction, right? So friction forces. Right? So if the distance, right, moved by the horse is 2 meters, right? Can someone let me know the friction, average friction force? Average friction force. Average value. A rough estimation for, actually this is not a correct problem, type of problem. So at least just to give you an idea, the average friction force, can someone let me know? You can make assumptions like that. You don't need to let me know the assumptions. So the average friction force. I have a feeling like that no one has any idea about the question, maybe. So let me explain it by myself. So now the potential was gained, some potential energy was gained by the load, right? We know that amount is, now the load is moved from here to here, here to there, right? Or else there to here, yeah. So the distance was, I told that 5 meters, right? So somehow in this direction, it cannot be exactly 2 meters. It has to be something roughly equal to 5 meters, but let's assume, right? For this case, let's assume. Now, this potential energy is, right, the change difference is equal to the work done by horse. Now, work done we denote as displacement of force, right? Displacement of force multiplied by the displacement of force along its acting point, right? So along its acting point, so this displacement should have happened along its acting point multiplied by the force itself. So in other words, work done is equal to Fx. So both these things are vectors, and F dot x, right? And the final answer is not a vector. Work is not a vector. It's just a scalar. So in this case, I have given you the x value. It is 2 meters. And the only force here is the friction force, as we can assume, right? So therefore, I assume the average friction force is work divided by x is equal to 125 divided by 2 is equal to roughly it's going to be 62.5 Newton, right? This is just to give you an idea about how to calculate average forces. This, of course, not going to be the correct answer in the real world situation. So this is just a rough estimation, right? So I hope that is clear. And going forward, so the basic idea I want to give you is the energy, or as the work done, is the force times the displacement of force, right? So you have learned these things in the first year. It is Fx. Now forget about these things here. Some of these things are wrong. So this one is definitely wrong. The reason is you measure energy in joules, power in horsepower. But in this case, they have compared energy and power. So power, you know,